Thanks for being here. I'm here to talk about the Boulder project. So really, I will talk about how do you actually create portable apps across controllers. And basically, this is, the date is wrong, but other issue with my other presentation. But what you have from a Boulder project is the ability to create portable applications. And I will show you exactly how to do that across your a variety of different controllers. Boulder is an ONF project that addresses the notion of intent. And as such, I will talk about some of the basic fundamental things around intent. So back at the beginning, you had the initial work on the, you had the initial generation of controllers. What was the early generation of controllers for? It was basically just an OpenFlow translator. So you had OpenFlow switch, which was programmable data path, and so your programmable data path needed a way to interface to. So you had to have the SDN controller in the picture in order to have the centralized control plane. Before OpenFlow, the OpenFlow-like interfaces were always used internally to the switch, so it was always on the same device as the switch itself. But when OpenFlow kind of changed things was by standardizing that interface and also making it possible to separate control plane from the data plane so that you could push the rules directly to the forwarding engine of the switch instead of having to go through a protocol or a set of tools, a CLI or other commands, right? So that first epoch of SDN required something outside the switch that would allow you to get access to the actual data path through OpenFlow. So initial controllers, basically NOx and also controller reference implementation for OVS, came in with very few functionalities, and then people started writing apps for OpenFlow, right? So this first generation of controllers with NOx, and then you had Beacon, which was the OSGI controller that inspired a variety of other controllers, and then Floodlight, which was Beacon with OSGI removed, and so on and so forth. Through this evolution of OpenFlow, this first generation of OpenFlow controllers, the main goal was to connect to an OpenFlow switch, have the ability to react on packet ins from the switch, and then push flow rules down to the switch in a either proactive or reactive manner, right? So that was this first generation of controllers. And so people started writing apps for these controllers, reacting on packet in directly linked to the OpenFlow protocols. So this initial step was very, very focused on the protocol. Then through that first epoch, like I said, it was really, SDN was about OpenFlow and OpenFlow only. And then afterwards, in the second epoch of SDN, what you had is the ability to have this control plane and data and application plane a little more distinct, right? So what you wanted to have is other potential southbounds and expand the notion of SDN to other plugins or other technologies. And that makes a lot of sense, but it enlarges the scope of what you are trying to do. And this becomes more closer to network management solution, or like the vision for these types of environments were there for a long time, where you had an integration platform that would allow you to virtualize your network infrastructure. And within this second phase of SDN, what you wanted to do is have a bunch of reusable functions like routing, path selection, AAA, so that the controllers evolved with complexity, with more pieces. And if you look at OpenDaylight today, it really feels like that. So OpenDaylight would be a Gen 2 or Generation 2 controller, basically. Then, so you have also the SDN controller, sorry, which was very, very difficult to write apps to. So in order to write an application for an SDN controller, it becomes challenging. You need to know about OpenFlow. You need to really understand what are flow rules, like is my flow rule in, and the debugging cycle is also very hard. And even today on OpenDaylight, I write the flow rule. Am I doing it properly? There's something weird happening within my component, and so when you're trying to debug this, it takes a lot of time, and it is quite consuming to actually create that. And not anyone can create these applications. I'm sure everyone in the room can do that because it's a bunch of smart people. But if you're actually not from the network industry, if you're an application, like a day-to-day application, how do you manage that? How do you create this environment for writing applications in a reusable manner? Today, with OpenDaylight, there's a variety of ways. Writing apps will go through RESTconf API. You can react on change and do WebSockets in order to subscribe to any notification. Like I was saying in other talks, OpenDaylight is a reactive platform, so it allows you to react on any change or anything that is happening. However, if you are writing an OpenFlow application, then that means that you have to react on all the OpenFlow changes or anything that you have, and it becomes very, very a large burden for applications developers to build applications with the knowledge of OpenFlow. In the end, it's really the best example I've always found with this is it is writing assembly language. It feels like moving registers and addressing memory space and stuff. So yes, we started there, but do you have to stay at that level of abstraction in order to go forward? So what's the solution? Well, many of us in the community have been talking about intent networking. What is intent? There's a great class. There was a great talk by Chris. I couldn't see it, but I think it was today that actually goes in what intent is. If you actually haven't gone yet, you'll see that it is a great talk. But I will give you a little bit of a resume because you need to know what intent is before understanding how you can leverage it to create apps and why Boulder is important. So intent is a non-prescriptive way to express what you want from the interface. So it is telling the network what you want versus telling it how to achieve it. The typical example that a friend of mine, Dave Lenrow at HP, always uses is if you have a headache, you want me to tell you that you have a headache and not necessarily take a pill just for the fun of it. So the reason why you are taking a pill is, or an Advil, is not because you want to take a pill. It is actually because you want to get the headache to go away, right? So it is important to have that non-prescriptive nature of what you desire within your intent so that you can process it properly afterwards versus doing, okay, I want an OpenFlow rule between this device and that device. why do you want that, right? So, and that's been the problem in writing applications for the first and the second generation controllers. How do you know what to do if you don't have the context of the request? If you don't have intent, how do you actually know how to react or make a change or when something goes wrong? If the only thing you have is push that forwarding rule from this to that, it is quite limiting from a network intelligence point of view. And intent is also portable. So what you want to have is an intent to what the one device or one controller interface should be portable to another controller interface, so that you can take my request and say, I want to reach Amazon tomorrow at 9 to do something very special, or I have an event and it has a live show and I want to have like a full network tomorrow at 7. That sort of request should be portable across different frameworks or different controller environments. So if you are writing an application, you want that application to be portable across controllers. It's also a universal language. So intent is universal. Any application request is expressible in intent terms. A lot of people will come to us and always say, oh yes, but in this technical use case, I want to be able to traffic shape this in order to do that, and so on. And when you actually dig enough, you will see that it can be realized into what was the intention in the beginning. So you can always go back, even with all the technical stuff, you can roll back and get back to intent. Also, intent renders application plane and controller plane mutually independent. Basically, what that means is that you can write apps that are not necessarily bound to the controller plane of the network. Also, intent usefully maximizes the degree of freedom in the controller plane function. What this means is that you can really have the intelligence done at the controller level. So the controller knows how to do things best. It knows what to do and how to do it more than anything else. So let's give it the opportunity to do it properly versus trying to always force the functions and the solutions down to the controller. Intent also supports request conflict resolution by the controller planes by actually including appropriate request context. And so if you know the intent, you can resolve the conflict. That's really what this means, right? So if you know what was intended, if two things try to override each other, then you can resolve the conflict. If you don't do it this way, what's going to happen is like with priorities and so on, if you don't have conflict resolution before you push the rule down, packets are simply going to drop, and I mean, it's not going to be processed properly. So you really want to resolve the conflict before just pushing priorities down to your flows, to the switch. Also, it actually creates a negotiation. So intent is not just a prescriptive thing, it is a negotiation that happens between a buyer and a seller. So the buyer is trying to seek something, and the seller is giving you the options. So in other words, what happens is that if you are asking the network, I want a 10 gig link tomorrow at 9, it might answer you, I can't give you a 10 gig link tomorrow at 9, I can give it to you at 8, is that okay? Or I can give you a 5 meg instead, right? So that's the type of thing that intent is not 100% like a black or white type of thing, and it has to be negotiated. In this third epoch of SDN, network service are consuming systems, right? So it is a bunch of consumers at the application plane, and what you want to have is that intent NBI, or that intent northbound interface that is sitting on top of the controller that allows you to leverage the controller plane independently so that you can move across any controller, and it's more of a standardized type of approach to the APIs of the controller. So what this actually allows you to do is tomorrow's controller simplifies the application development. You tell the network what you want and not what to do, right? So then you manage the resources and the application lifecycle through intent. So you connect this to that, modify this traffic, apply policies to traffic between this and that is all of ways that you can do intent. So the Boulder project. Well, the Boulder project is an ONF funded project that is aiming at getting good intent runtime and data models and working within that space, right? So from the beginning, what it has is it starts from a data model and a way to structure the intent and drills down into an executable runtime that you could technically port across controllers or keep standalone or do other things with. So, but at the core of it, the first thing you have to have is the ability to have this northbound that is similar across different controller implementations. There has been other work in that area. I mean, it's a lot of people have been working at higher level abstractions on top of controllers like Frenetic, Maple, even OpenDaylight group-based policies is intent-related work. It's policy, but policy and intent are different and similar at the same time. I will dig into that in a bit. ONOS intent, et cetera. So there's a huge need to try to standardize some of that and be able to do the work. So Boulder is the ONF open source project, and it will be a community project. I mean, it is a community project, but we'll officially launch a little later. We did a bit of proof of concept, which I will show shortly, but Boulder is ONF's way to address some of the how intent-based applications should be created. So this new way to write applications, right? So it's how do you write a portable app? Well, the first thing is you need to be able to do it in a controller agnostic fashion. What that means is it cannot be bound to the language structure of the controller. You have two choices. You make it through a REST or a northbound interface API type of call, and then it is only at the interface level. But that's good, but your application will have to run somewhere. And in some cases, you will also want to have a potential runtime, right? So you want to, if you think your controller is kind of an OS for your network or a network operating system, then you might want to run an app that will give you a process ID, a little bit like an OS, and tell you, well, that application no longer is running and reacting to the intents that are coming and going, right? So the notion of a runtime is an important thing because you will want to have a temporal aspect to how your intents live and die within the system. The first step, though, is to simply push static structures down to your controller environments. So first step, data model, the ability to create the underlying grammar for intents across different controllers. Second step, have a runtime, an executable runtime that is portable, that is like, think of it as a virtual machine for Java or whatever. So what you want is a JVM-like equivalent with intent primitives that allows people to react and create applications on the controller itself. So if you're doing it external, API is great, but in many cases you will want to have a closer feedback loop. You will want to run localized applications, and you will want to make that through an intent-based system. So that runtime with the primitives, with the primitive instructions becomes fundamental. And that's why ONF is so key in making this happen, because the structure of the package needs to be standardized eventually, right? So a little bit like if you are familiar with OVFs or virtual machine images, it is the same thing. At some point, you need to have a packaging structure that allows you to determine what is inside that and how can you port that across controllers. It's not only about, yes?
Why would you do that versus leveraging orchestration?
You'll actually be doing both, okay? So one is not, that's what I was saying. There's actually two ways or two things that you will want to do from an intent perspective. Orchestration, like OpenStack or anything else, will call the intent API and request intent and manage it from orchestration lifecycle. But if in some cases you want to create an internal component, I'll take OpenDaylight as an example. If you want to write an OpenDaylight plugin today, you have to go through the whole MDSAL reaction thing where you're reacting on an event and you create a localized bundle, and that bundle gets deployed to the controller and it provides feature X, right? So it provides something that's actually running there. In some cases, you will want to create higher level intent that are based off intent primitives, okay? So it's a recursive intent that includes other intents that you have underneath. So let's say, I don't know, I want Skype to work from my place to my neighbors, and I want that in a very, very particular way. So I will create a new verb or a new grammar for that intent, and that's going to leverage connectivity intent and security intent and traffic redirection intent. So that composability of intent is why you will want to have a way to package this so that you can expose newer intents without having to recreate a complete plugin for it, or like have to extend the core controller. If you extend the core controller, good, but then you end up with a very difficult way to reuse components across, or to reuse service functions across, or anything that it lives closer to the switch, L2 switching, like like the basic fundamental network services. So having the ability to have a local runtime will allow you to port network services or network applications that live within the functionality, but that doesn't prescribe you from using the REST API in order to access that. So you're absolutely right. In many cases, it's going to be orchestration. In other cases, if you're talking about the typical app, which everyone does for their controller, L2 switch, or I'm writing a DHCP agent, or everything that you're writing for your controller is very specific for your controller, and that's the type of other type of network apps I'm referring to. And so that's basically that new way to write application implies the ability, what you want to have is that application package root, and inside that you will have a manifest. So the manifest, what it does is it tells you what intents are required by that application. What verbs do you speak? What capabilities are needed by the controller in order to run that app. So it does the capability discovery from the intent interface, but runs it localized. Intent scriptlets are things that you can use within your intent, and if you want to do imperative programming of your intent, right? So it's always the balance between declarative and imperative programming for intent. in the declarative world where you just push all the intent grammar and the system takes it all in a declarative way, that is one use case. In other cases, when you have a notion of time or something that needs to happen over time, then an imperative approach to it will also be useful. So in this case, that's the reason why we're not prescribing one approach or the other. You can go declarative using the API or the REST interface, but you can also go imperative by writing scripts, right? So that, yes?
With the packaging, if you create an app, so the app is clear about its intents. Now if you create one more app, it is also clear about its intents. But they both don't talk to each other. They might have some kind of overlapping situations where they both want to do some part as similar.
Mm-hmm.
It could differ in some other things.
Mm-hmm.
But the underlying flow rules after this, whatever these apps generates, they don't know. They would create conflict, right? When you are actually executing them on the network,
Mm-hmm.
they would, how do you
Yeah, exactly. And conflict resolution has been like a large piece of work. Like a lot of folks at HP have been working on that. And so conflict resolution at that layer, that's why intent is important, because like I said earlier, you can actually resolve conflict a bit. But then that's also why I feel that runtime is important because it allows you to react when you have that conflict. So you can have logic that will allow your app to say, okay, when that intent failed, what should I do, right? Or like, should I insert a new intent, or like what is the overall behavior that you want from that application perspective? And even in the intent interface, there is a notion of a like webhook callback that you have to have a way to say, okay, I can no longer realize your intent. And as an application, you will need to react to unfulfilled intent. So I can no longer, if you can no longer fulfill the intent, it has to be done that way. So how does it work? Okay, what's been done so far within the Boulder project, within the NIC project, is really the notion. NIC is for OpenDaylight. It implements the same native interface, or a very close data model to what Boulder has, and it will. And we are trying very hard within the community to evolve that to be the same canonical interface. I mean, the same interface with a native implementation within OpenDaylight. So what you have is a notion of subjects, which is like who, predicate what, objects, again, another who, and then you have also notions of constraints and conditions, right? So constraints is a little bit of how that should be realized, and conditions is more of an event or environmental thing. So what time or when and so on. So that is your basic grammar. So Bob connects Alice at 10 gig from 9 to 10 would be how you start and decompose that. And so you take this statement as an intent, and then you push it down through this decomposition engine, and it will translate it and realize it as part of its implementation. And on that, you need to know who Bob and Alice are. So in other words, the controllers need to know what Bob and Alice is. And same goes for the different, like the verb needs to be handled by the controller, like connects and constraints, same thing. And that's why the manifest I was talking about is used, or the capability discovery API is also used in order to know what type of endpoints can you talk about. Can you talk about Alice or Bob, or like if they're individuals, I can talk about 2 individuals, or I can talk about 2 endpoint groups, because we don't want to restrict. And the way we're working on this is it could be applied to any domain. It starts with networking, but you could ask for storage, or you could ask for compute. Nothing precludes you from doing so. Yes?
So in that use case example, shouldn't we have the constraints and conditions as a part of predicate, not object?
Actually, it is, you're right in something that, I mean, this example by object here was target, which was like another who, so it's your part. And constraints and conditions were attached to the object. The reason why we chose subject, predicate, object was to mimic sentence or grammar that you would have. But you are right, the data model doesn't completely follow this because constraints and conditions are actually intent, part of the intent and not necessarily it's not part of the object, okay? So, so yeah, we did a proof of concept at the ONS Summit, and there will be a lot more community involvement from now on, and we're trying to gear up to actually get the community. We're getting ready to get more community involvement, like the infrastructure and everything. So we're working hard on that, hoping to get something by the ONF member work days this fall. So, basically, what we did from ONOS perspective in order to map to ONOS is what you have is the application does the initialization. It does the capability requests, like I mentioned, and the verbs and responses to something called ONOS Runtime Engine, and you'll see that in a bit. But ONOS Runtime Engine is a mapper, so it maps from the grammar down to ONOS proprietary intents for the ONOS controller. And so internal to the ONOS intent, what it does is it does a host-to-host intent and some path intents, so it gets decomposed to path intents. On the OpenDaylight side of things, the way we are doing this is same thing, application init, capability requests, capability responses, but engine pushed through OpenDaylight NIC. So it's a pass-through. So we don't have to have like a mapping driver part of the structure because NIC is so close. I mean, there's a little bit of tweaks and it's still proof of concept code, but it is very close. So we are not using any specific driver or mapper or like translation layer. And it's pushed to the NIC project or Network Intent Composition project in OpenDaylight. And then in the NIC project, the actual feature gets realized through the group-based policy. So the group-based policy project is the one that realizes the intent. So what we did as a demo application, and I will try to show you like a small video, which, well, some of you saw it at the demo theater yesterday, but I will still re-show it. But what you have is you have this little application which has 2 waypoints, 1, 2, 3, and you want to make sure that you can get an ONOS domain connected to an OpenDaylight domain through intents, and that's like the basic scenario that calls allows, right? So it's very 101, but it was to verify if you could get the whole discovery process and everything else as a framework to move forward from this. And I think that was a success. So you can find the Boulder code for on the ONF's Boulder Intent NBI GitHub. I will just show you a quick video, and then I will check if you guys have any questions on Boulder. So I'll just skip because there's a bit of intro. So basically, when you want to create, when you want to create an application, what you do is you create your basic directory, and from that directory, you generate a scaffolding. So this scaffolding is you use Yo in order to generate a Boulder application. We'll create all the basic files, so it's like a Maven archetype or a template. Will this application, you saw the question here though, will the application expose additional intents? I mentioned that it was all about like being able to expose newer intents. So whatever you've done here can actually be re-exposed as another intent and reusable if you want to do so. So what it creates, it creates some build stuff, and then manifest.json is the manifest I was talking about. Then in intents, you have like a little app or default entry point for the application, scriptlets or scripts that you can import, and that will be put in the context of the execution environment. So what the execution environment does today is it simply gives you exposed object to the intent structure. Okay, so it's like a small scripting engine that exposes you with the internal object structure so that you can run it either internally or externally. I'll let it play. Yes, I'll have to quit in a bit. Right, so in the manifest, you have the name, the version, the information, homepage, a bit about the application. Also, the capabilities is what's important. What are the verbs that you're trying to get from the controller? You want an deny, you want an allow verb between two endpoint structures or endpoint groups. And then in the scriptlets, oops. So yeah, so that's the structure. And basically, the app starts with a main, and then the main allows you to simply create intent. Then you can use very simple verb structure and grammar in order to create your application. And yeah, and so then if you have like something like get port or and you want to have like a more advanced behavior, you can create like scripts that's going to run alongside your intent and do stuff as required. I'll just fast forward because otherwise you won't see it. So what we're showing here is we have an ONOS domain and OpenDaylight domain, the thing I showed you before. And what you want to be able to show is that whenever you run your intent application, it is going to work with both controllers and get the intents down to the two controllers in order to create an end-to-end service chain or path. So in this case, what you have is you want to have waypoint. First intent is an ONOS intent that's going to work on 2 MAC addresses. And then the second with no constraints and no condition, that's the 2 nulls. And then the other intent is 2 waypoints with an allow verb that actually is on the OpenDaylight domain. You saw I had like 2 gets for 2 engines, one for OpenDaylight, one for ONOS. And then you can actually view that the intents exists in both controller environments. So that's pretty much, and you'll see that it's from waypoint 2 to waypoint 1 or something like that. Waypoint 2 and waypoint 3, sorry. Yeah, just cut and paste them. So that's pretty much what Boulder is today. Now we're actually working at getting more vocabulary, trying to come up with a standard set of primitives so that things don't have to, so that they can be standardized and it doesn't become a mess of like 200 verbs that actually becomes very difficult to manage. So yes, you can add more verbs in the future and like expose new intents, but you want to have a basic set of primitives, the basic instruction set that you use to create these applications. So that's pretty much what Boulder is about. I really recommend getting in touch with the ONF guys in order to get more, or OSS SDN to be more precise, guys to get more information. And shortly there will be a place for the community. So any questions? Perfect. Oh, yes?
So the ONF have their knockdown interfaces.
Yep.
Is Boulder coming from that project?
It's coming from a document from that project. There's an intent northbound interface document, and so the models that we use is part of the discussion around that document. So it is linked a bit to that document, but Boulder is not aimed to be like, it's not an implementation of a standard yet or anything else. It's an experiment, but might help drive and understand what are the needs and what needs to be, like what we can do there. So that's, yeah, but it is linked. It's the same people that are involved in both. Dan, yes?
So are the ONOS and OpenDaylight runtime sort of long-lived artifacts from this? You can then write all kinds of controller-neutral applications on it?
Yeah, so that's the idea. So the idea is to have these long-lived runtimes that are sitting in both ONOS and ODL, and that you can, instead of writing an app for ODL, writing an app for ONOS, you technically could have apps that are written and work in both environments. Today, we all are doing our own little network app on each of the communities, and that's why like the runtime is an interesting approach to it versus only the REST calls. I mean, and the REST calls are also very important because they allow you to leverage the internal functionalities. So you do it in OpenDaylight, you do it in ONOS, but it's not portable across the two controller domains, only at the REST interface. Thank you. Any other questions? Well, thank you, guys. If you have any questions, feel free to reach out to me, and have a great summit. Controllers for it was basically just an OpenFlow translator. So you had OpenFlow switch, which was programmable data path, and so your programmable data path needed a way to interface to. So you had to have the SDN controller in the picture in order to have the centralized control plane. Before OpenFlow, the OpenFlow-like interfaces were always used internally to the switch, so it was always on the same device as the switch itself. But when OpenFlow kind of changed things was by standardizing that interface and also making it possible to separate control plane from the data plane so that you could push the rules directly to the forwarding engine of the switch instead of having to go through a protocol or a set of tools, a CLI or other commands, right? So that first epoch of SDN required something outside the switch that would allow you to get access to the actual data path through OpenFlow. So initial controllers, basically NOx and also controller reference implementation for OVS, came in with very few functionalities, and then people started writing apps for OpenFlow, right? So this first generation of controllers with NOx, and then you had Beacon, which was the OSGI controller that inspired a variety of other controllers, and then Floodlight, which was Beacon with OSGI removed, and so on and so forth. Through this evolution of OpenFlow, this first generation of OpenFlow controllers, the main goal was to connect to an OpenFlow switch, have the ability to react on packet ins from the switch, and then push flow rules down to the switch in a either proactive or reactive manner, right? So that was this first. This becomes more closer to network management solution, or like the vision for these types of environments were there for a long time, where you had an integration platform that would allow you to virtualize your network infrastructure. And within this second phase of SDN, what you wanted to do is have a bunch of reusable functions like routing, path selection, AAA, so that the controllers evolved with complexity, with more pieces. And if you look at OpenDaylight today, it really feels like that. So OpenDaylight would be a Gen 2 or Generation 2 controller, basically. Then, So you have also the SDN controller, sorry, which was very, very difficult to write. Thanks for being here. I'm here to talk about the Boulder project. So really, I will talk about how do you actually create portable apps across controllers. And basically, this is, the date is wrong, but other issue with my other presentation. But what you have from a Boulder project is the ability to create portable applications, and I will show you exactly how to do that across your a variety of different controllers. Boulder is an ONF project that addresses the notion of intent, and as such, I will talk about some of the basic fundamental things around intent. So back at the beginning, you had the initial work on the you had the initial generation of controllers. What was the early generation of controllers? And so people started writing apps for these controllers, reacting on packet in directly linked to the OpenFlow protocols. So this initial step was very, very focused on the protocol. Then through that first epoch, like I said, it was really, SDN was about OpenFlow and OpenFlow only. And then afterwards, in the second epoch of SDN, what you had is the ability to have this control plane and data and application plane a little more distinct, right? So what you wanted to have is other potential southbounds and expand the notion of SDN to other plugins or other technologies. And that makes a lot of sense, but it enlarges the scope of what you are trying to do. And